some more examples. Let's try to apply those strategies. So this first problem, which side should we start with probably? You can always pick either side, but
1 plus tangent.
the left, because the left has more to work with, more you can grab onto and do things with it. So rewrite it again. If you do not rewrite it again, you will not know how to do these. So just make sure you do that.
Let's take that tangent and turn it into a sine cosine.
Ah, so Caleb's applying strategy 3. Does it matter you remember it as strategy 3? No, of course not, right? Sine and cosine, I think that's a smart way to go. Let's do it. So he's saying 1 plus tangent is also known as sine over cosine. And cotangent is also known as? Yep. Those are your basic reciprocal identities coming into play. From the unit circle. They don't come from somewhere mysterious. All those identities either come from the thing I showed you a second ago, or from the unit circle. And just thinking about the unit circle, that's it. It comes from picturing a triangle in the unit circle, that's all. Now, Caleb's saying next step is a crazy one. He's had a little more experience than you guys have with this. Yeah, so you can see it's smooth for him already. Clever one. What's he talking about, a clever one?
It's when you make the denominator.
How's he know? Oh, because we have fractions, right? So you want to like smash those fractions together. That's a good idea. Stuff will maybe cancel, we're hopeful. So on the bottom, what's the common denominator? Well, the only denominator is sine, so we want this one also to be sine, so we use a clever one to make it be sine. And on top, so we don't waste a whole bunch of steps, the only denominator is cosine, so we want this one to be a cosine as well, so
I'm not calling you. Sorry. That's my advice with LS. Just don't be safe.
okay, so now these both have a common denominator, right?
Yes.
And up on top you've got sine plus cosine. Are we good? A similar thing happens on the top of this one. So the common denominator is cosine. We have a cosine plus sine.
And then you're going to have another common.
So remember, what you're trying to do when you establish an identity is turn one thing into another thing. We in fact want to turn this thing into this thing, if it's possible. Those problems you saw in the last assignment were designed to let you use your calculator and see if it seems feasible. If you put these in your calculator, I'm thinking they're going to copy onto each other because the book said it's an identity. Maybe we can't trust it, or we have yet to prove it. We'll see what happens here. So you always want to keep your goal in mind. That's one of my pieces of advice on that sheet as well near the end. Keep your goal in mind. Now this doesn't look like this yet, so it's not really helpful yet. Is there anything else we can do that's kind of obvious? Flip it, yeah? Flip it, yeah. Write it flipped. However you want to say that. That's a smart idea. You could also just look at it right now and see something. That stuff? It's the same as that stuff. So something cancels out here. I think if you flip it, though, it's a lot easier to see. It is, you're right. So that'd be a fine step for you to write that. If you're unsure at all, though, you want to actually flip it.
So you can treat it as just okay, that's
so just because these are like backwards and forwards, that doesn't matter at all. It's the same stuff, right? Added is added. This term is the exact same. There's no pluses or minuses in here blocking us up to prevent the cancellation. This is just 1, right? So that is sine over cosine. That's kind of like tangent, right? But where were we trying to go? So look at your goal. Now you're going to have to look where you're trying to get to and make a decision, because tangent, is tangent actually that stuff?
Yes.
You might not be sure. I think we were closer when we were back here. So I'm going to back up a little bit. And this is the dangerous thing in identities. So as you're starting out, don't do this unless you're kind of out of options. Us looking at that, it's not exactly obvious how you get there, right? So the dangerous thing you can do when you need to is work a little bit on the other side. This is not an equation. We can't do things to both sides of it. But I can mess with this stuff over here and try to see where I'm getting to a little more clearly. Try to remove the smog, remove the fog, remove the giant tree in my path. Does that make sense? So there's kind of a tree in my path right now. It's not giant, it's a small one. So really over here, what do we have? Secant is also 1 over cosine. This is another problem. Cosecant is, and since that's a fraction again, if you flip it, won't you get this? So really, can't we write that this is equal to, like the reverse flip? We can say that's equal to this, can't we? That's the clever step that we couldn't see. There was a tree blocking our path. So that's why we went over it with a chainsaw, if that makes sense. This step is legitimate, it's just extremely clever. Does that make sense? Maybe not extremely clever, moderately clever, whatever. It was clever. Hard to see. And now from here to here, it's not that hard to see. 1 over cosine is secant, and 1 over sine is cosecant. Yay, I have one chain that goes from my left side to my right side. I've proved that these things are the same for every value of y. And that's the whole point here, is that you could replace this stuff with this stuff if it helped you get stuff done. And that's why we're doing things in this unit, the main reason anyway. Okay. So I didn't start out with like a super simple example like I would know for 2. So if you want to see those, go look at the video. Let's look at this one. What do you guys think? Which side should we start on? Much more stuff to work with. Wise. So I'll write it down again. Say, okay, that's equal to what? Well, what can we do with it? We're trying to just get signs. We want some stuff to go away at least, right?
Well,
1 minus secant squared.
There's all kinds of options we have on this one. I bet there's like 7 different ways to prove this. We could distribute, right? You could use the Pythagorean identities, those versions of the squareds, to change stuff into other stuff. That'll work too on this problem. You could even factor this as difference of squares because it's 1 minus thing squared. I'm going to try the easiest thing first. Let's just distribute and see what happens, shall we? So distributing. Did you have another way you wanted to do, Emma?
Yes.
Yeah.
What was your way?
1 minus secant squared x equals negative tangent squared.
Yes, that's also good. Let's do that one in a second. Let's do it a different way. We'll show a couple ways to do this one. That's smart. I'm just going to see if distributing works because that's easy, right? Like, so now I've got this. Who can tell me what to do now? It's cosine squared x minus 1. Why, Jamie? These cancel each other out because really, I mean, I should write down another step, but it's okay to erase sometimes too. That's really just this, isn't it? And then this is almost like a version of the Pythagorean identity. This you definitely 100% have to have memorized. So Emma did this another way a second ago. It's not necessary, I don't think, to memorize all those. I still mess them up to this day. I'm not lying to you. So all I have memorized is this. I know that sine squared plus cosine squared for all angles x is always 1 in trigonometry. And see, that lets me solve this problem, but it'll also let me do it the way Emma does here in a second. Watch. So we've got cosine squared, right? So you can solve this. You can manipulate this. That's what's step, what is it? What is it? Hint 5 or 6 on your sheet is? Manipulate those basic identities. Is it 5 or 6? I don't know. Is 5? Okay, thanks, Mr. Freeberg. So I want to solve in this problem for cosine squared, so I should subtract sine squared to the other side, right? So now this is equal to 1 minus sine squared minus 1. Right? That minus 1 is this minus 1. And you've got 1 minus 1. And you've also got negative sine squared, which is where we were trying to get to the whole time. Proof.
Now
also for the third one from the top, the cosine squared x minus 1, if you were to substitute -1 for that, you should get the same answer.
Yes, you're right, but that's a little more dangerous, I think. But smart, smart. Let's go back up and do it a different way, because I think Emma wanted us to think about it a totally different way. So right here, starting with the same side, she substituted something else. I think she did something like this. You tell me if I'm right. So going back to the basic, the only thing I have memorized. There's other versions of this, 2 other versions. If you want a tangent squared version, what should I divide by here if I want a tangent squared version? Cosine squared. See, this doesn't take a lot of thought. If you're like, oh, I know there's one with a tangent squared in it, which is something you should know. You're like, I don't know how it goes exactly. Make it happen. If you divide it arbitrarily here, you have to do it everywhere on both sides. Right? Here's your tangent squared that you knew was like another identity. And then just see what happens. That's 1. What's this? Secant squared. There's the one of the other 2 versions. That one's useful here because we've got a secant squared. Secant squared can be replaced by this stuff. So I really have 1 minus, ooh, careful with your parentheses.
Can you resubstitute?
Yeah, I mean, it's up to you. This is logic, right? All we just said is secant squared is that red stuff. That's all I did so far.
So like, I'm saying, could you resubstitute like 1?
What do you mean 1?
Like, in that equation, could you resubstitute the 1?
Could you substitute 1 for secant squared minus tangent squared? Yes.
Could you substitute 1 for, I wouldn't help each other.
Yeah, you can substitute any version of 1 that you want. Sine squared plus cosine squared, secant squared minus tangent squared. There's different versions, so yeah, you can, but that's not usually something that helps too much, so good question. All right, what happens inside there, you guys? -1 plus 1. And we have minus tangent squared x. Right? That's not cosine squared minus tangent squared. It's cosine squared times negative tangent squared.
The following students to student services, please. Ben Payson, Barry Ramsey, Kylie Bonino.
So I'm going to say do that.
Haley Fox, Natalie Phillips, Andy Wallow, Caleb Freeberg, Brandon Johnson,
Just wait till the end of this.
Katie Wolin, Jacob Garner, Sam Goodman, Max Martinez, and Connor Moss to student services, please.
There's columns.
Okay, so who can tell me what to do now? Emery?
Next one, next one, square back is the same thing as negative sign of.
Yes, and I moved the negative out in front. You see that?
Oh. And then you can just,
And that's what we wanted. So there's a totally different way to do the same problem. I bet there's like 3 other ones. Or an infinite number of other ones. It's just which ones are easiest and which ones aren't. You can go if you need to. Should we look at 2 more problems? I think we have time for 1 or 2 more. Let's do it. So let's see, what other ones does this one have for you? Ooh, let's do this one. Anything in this class. This is the worst hour. I know. I know.
Mr. McGee is not a follower.
Not today. Not in this hour ever, apparently. Oh, hold on. Well, Caleb would have started calculus right away this year, but I didn't have it just for him. So, sorry, Caleb. So, 2 more. Pick. It's a judgment call. You could try either way.
I mean, it's almost as
I would go left.
well. I do.
I hear more left.
I do right because you It's just a,
Oh, okay, I
Got that two.
Yeah.
Let's start on the right-hand side just to be risky. If you think about this one, some of these, as you get better, once you get real good, you can just see it click, 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 click pretty far. You might not know exactly how it's going to work, but you know kind of how it's going to work. I see kind of it working from this side.
Well, we're trying to.
Because like cosecant squared is going to be what? 1 over sine squared. You could use a Pythagorean trig identity, like we're using it over here a second ago, but that's got a sine squared on the bottom, so I'm kind of seeing it already. You guys are. So this is 2 over sine squared x minus 1.
so then it's just the terms.
The following students to student services.
So then what?
Katie Wolin, Jacob
Turn
Garner,
that, turn the minus
Sam
one into
Goodman,
sine squared.
Max Martinez,
Sine squared.
Connor Voss, Vance Zolch to student services, please.
And then just the terms are equal to each other, right?
Yes.
There you go.
Why do you have that one sentence? Okay, that one was confusing. So let's just.
So look at what you need. Look at what you have is pretty close, right?
You can change sine squared x to
You can go 1 over.
Sine squared x is 1 minus cosine squared x from that basic identity.
We have
So
one minus. And 1 minus cosine squared x, don't we?
Yeah.
distribute,
The negative-
and bam, you've got it. I think, don't you?
No, because we've got a 2.
2 minus 1 is 1. 1.
Oh, okay.
Minus negative is plus. Yes. Done. It might have been easier to go on the other side. I don't know though.
Let's try it.
If we have time, I will. Let's do another one first though. Okay, so right side or left side? What do you guys want to do?
Oh yeah, right side.
I like
Yeah, there's not a lot we can immediately do with this. I'm thinking conjugate. That's the only thing I can think of on this side is apply a conjugate. You can do the conjugate at the top or the bottom and see what happens. You guys are saying the right side though, so let's do that. So you want to change the sine and cosine, Caleb?
Yeah.
Okay.
What you have to do every time, you want them to all just it should be on this list like it was last time, but it's not.
It is.
Right.
Okay. Right? What's the next natural step, guys?
Oh. Yeah, it's never been said here, so I never noticed that.
Real complicated math here. Whoa, that's crazy.
I still don't see a squared up there, unfortunately, though.
That's okay.
Let's just square it and see what happens. Cosine squared is cosine squared, right? And now 1 plus sine squared is like, couldn't you write that like this? Anybody seeing anything now? Jamie? Oh, it's 1 minus sine squared. Okay, be real careful here though. Can you just cancel like this? Way no. What do you have to do with this thing first down here? Factor it with difference of squares, right? That's difference of squares, so I'm going to make the equal sign go this way just to be crazy. Difference of squares has 1 minus and 1 plus, right? Chop. Prove it.
Couldn't you also?
Notice, If we'd started on the other side, what would have been our first step? I said at the beginning. Conjugate. There's that side. There's a conjugate clever 1. The next step would be, oh, that's just 1 plus sine of x squared. That's just this. That's just this. And we'd be going back up the ladder this way. So, and that's probably definitely not the only way to do it either. See you next time.